How's it going? It's your old pal, Mr. Cook, and we're going to work on the Unit 7.1 and 7.2 extra practice worksheets. So have out your fundamental identities worksheet, because we're going to be referencing back to these a ton as we're going through them. So the key to this is just kind of use the identities and simplify expressions as much as you possibly can, citing the identities when you use them, very similar to a proof. And then just kind of stopping when you can't use any further identities. Okay, so we're going to work with the first 8 problems, which are all simplify problems. So we don't really have any direction on where to bring these expressions or when to stop simplifying them. So we're just going to simplify them when they look like easier. You know, like if it's 2 expressions, simplify them to 1. You know, that kind of stuff. Okay, so starting off with the first one. A standard go-to procedure for getting these expressions simplified, and then, you know, when we move on to the next ones, when we start to verify ones, the standard procedure is just to turn everything to sines and cosines. So the identities that you'd use for that are like, you know, if you've got a cosecant, you'd use a reciprocal identity and turn that into a sine. It'd be 1 over sine. If you had like a secant or like a secant squared or whatever, you know, and you want to turn it into sines and cosines, you can turn it directly into 1 over cosine. And then you'd use, for tangent and cotangent, you'd use the quotient identities. So you use a quotient identity to turn tangent into sine over cosine, and you'd use cotangent to turn it into cosine over sine. So this is a procedure that I'm going to use very, very regularly to turn all of these kind of like into the same type of thing. Because you don't want to work with too many different types of ratios. So since you can turn everything into sines and cosines, it's kind of like a nice little step if you don't see something that you can do. And that would work really, really well in this first case, because I've already got a sine here, and I can turn this cosecant into something that has to do with sine by using a reciprocal identity. And that reciprocal identity is, again, going from cosecant to 1 over sine. So I'm just going to turn it into 1 over sine, so I get sine of x times 1 over sine of x. Using that reciprocal identity. Then if I just multiply these two together, sine times 1 over sine turns into sine of x over sine of x. And then that'll reduce real nicely, because just like any other fraction, if I have a number over itself, it reduces down to 1. And that doesn't get any more simplified than that, you know, because 1 is pretty simple. And that would be the first problem that we'd simplify. The second one, I've got a cotangent of negative x, so I go over to my list of identities, and I see that cotangent of negative x is an even and odd identity that turns into negative cotangent of x. What it means is that tangent and cotangent are negative, they're odd identities, they're odd functions. So if you have a negative inside, it just moves to the front. Same thing is true for sine. And then since cosine and secant are even functions, the negative just gets absorbed by the expression. And there's other mathematical reasons for that, but we're just going to stick with kind of like an easy way to kind of remember what they kind of represent there. So anyways, the cotangent, I'm going to use the even and odd function for that one, or even and odd identity. And this cotangent of negative x turns into the negative cotangent of x times tangent of x. And then from there, I can turn this cotangent into a tangent by using this reciprocal identity. Cotangent is equal to 1 over tangent, so that's what I'm going to do. So this turns into negative 1 over tangent of x. So that's a reciprocal identity I just used there, times tangent of x. And then very similar to the first problem, tangent times 1 over tangent is tangent over tangent, so I have negative tangent over tangent. And of course, that reduces down to 1, so I've got negative 1 for my answer. And it doesn't get any more simplified than that. We are good to go with that. Cosecant and cotangent. So, I mean, you see that there's a connection between cosecant and cotangent with these identities, but that actually doesn't have anything to do with this particular problem. The easiest way to work through this one, in my opinion, is to just change these both into sines and cosines. So I'd use my reciprocal identity of cosecant, and I'd use my quotient identity of cotangent. And I just turn this expression into 1 over sine for that, for the numerator. And then the denominator, instead of cotangent, it becomes, for the quotient identity, cotangent becomes cosine over sine. So this is going to be cosine of x over sine of x. Now I have a fraction divided by a fraction, and you guys might remember this rule from algebra or just any arithmetic class that you've taken. If you have a fraction divided by another fraction, it's the same as, taking the numerator, keeping it the same, changing the sign from division to multiplication, and then flipping the fraction. In other words, finding the reciprocal of the denominator, so 4 over 3, and then you just multiply straight across and reduce and all that stuff. Same rule here. I have a fraction over a fraction, so I keep, change, flip, and then I multiply straight across because it's a fraction, so 1 times sine is sine. Sine times cosine is sine cosine. Then I can reduce the signs, cancel, just simplify those. Sine divided by sine is 1, so I just get 1 over cosine. And 1 over cosine should be familiar because 1 over cosine is secant. That's a reciprocal identity. So just one more thing, reciprocal identity turns that into secant. And I am simplified now. Okay, next one, number 4. So in some cases, you just want to let your algebra instincts take over. So this sine plus cosine squared, that's really the same as saying sine of x plus cosine of x times sine of x plus cosine of x. So this is just a standard, two binomials multiplying together. So you do the same thing that you would in your algebra class, and that's FOIL or distribute. So sine times sine is sine squared. Sine times cosine is sine cosine. Cosine times sine, well, if I just, switch them around in different order, sine times cosine is sine cosine again. And then cosine times cosine is cosine squared. Okay, now I'm going to combine like terms here. So sine of x plus sine of x is 2 times the sine of x, cosine of x. And then I also have this sine squared and this cosine squared. And that should sound familiar because sine squared plus cosine squared is a Pythagorean identity. Yeah, there's that stuff that's adding in the middle, but if we just have sine of x squared plus cosine squared of x, that's the Pythagorean identity that allows us to turn that into 1. So using a Pythagorean identity for these, that just turns into a 1. So it's 1 plus 2 sine cosine, and that's about as simple as it gets because I use this little identity to shrink down the expression. So that's the answer for number 4. Number 5. Secants and tangents. I'd probably give this the same treatment I would number 3 and turn it into sines and cosines. So I'd use a reciprocal identity for secant. So secant is the same thing as 1 over cosine of x. Tangent, I'd use the quotient identity for that one. And that turns into cosine of x over sine of x. And then once again, since they're fractions over fractions, it's the whole keep, change, flip thing, so this becomes 1 over cosine of x times the reciprocal, so sine of x over cosine of x. Multiply straight across, then I get sine of x, the reciprocal there, yeah, cosine. I messed something up. Oh, tangent, dang it. Sorry about that. Tangent's quotient identity turns into sine over cosine. That's my bad, sorry, I'm trying to do this too fast. And then the reciprocal then would be cosine of x over sine of x. There we go. That's better. Come on, Mr. Cook. So then we do 1 times cosine, which is cosine. And then cosine times sine, which is cosine sine. And then just like any other fraction, the cosines cancel out. And I'm just left with 1 over sine of x. And we've seen that before as a reciprocal identity. This turns into the cosecant of x. And we're all done. That's as far as it goes in terms of simplifying it. Okay, number 6, there's probably like a good chunk of ways that you can do this problem. I think that probably the easiest way to do this would just be to recognize that this 1 plus sine of x is a part of this identity over here, 1 minus sine squared, because each one of these like 1 minus expressions that you have, or an expression squared minus 1, like one of these trig expressions, like you can factor these because they're difference of squares problems. So like when I see that 1 minus sine squared, that's really the same as saying 1 plus sine of x times 1 minus sine of x, because a difference of squares factoring problem. So that's why, like, as soon as I saw that 1 plus sine of x, I thought, hey, that's part of the factor of that. And I can get this 1 minus sine squared from cosine squared. So those are the steps that I would take for this particular problem. I would turn this cosine squared using a Pythagorean identity into 1 minus sine squared of x. And then I'd have that 1 plus sine of x in the bottom. Then I'd factor this expression. So using difference of squares, I get 1 minus sine, let me write that out the front, the first stuff too. 1 minus, and then it's 1 minus sine of x and 1 plus sine of x in the numerator. That's what that factors to be. And then in the denominator, I've still got that 1 plus sine of x. And those 1 plus sine of x's will cancel on out, and I've got 1 minus sine of x. I distribute the negative in there, and I get 1 minus 1, and then negative times the negative is a positive, so plus sine of x. And then 1 minus 1 is 0, and so that just leaves sine of x as my answer. And that's about as simplified as it gets. Man, look at that. We went from here to just regular old sine of x. The interesting thing about this, and like one of the craziest things I think, is that like these two are mathematically equal to each other. I mean, there's bound to be some like domain restrictions just because of that 1 plus sine of x right over there, because this can be -1 at some point. But like, regardless of those domain restrictions, this is like an equivalent identity, except for those particular values. That's crazy to me. Anyways, 7. So number 7. I would probably just whenever I see like a 1 and a cosine or a cotangent or whatever, I always just go over to my Pythagorean identities because they're all kind of like that, So I do see that 1 plus cotangent squared is on my identities. It's right there. It can turn into cosecant. So that's what I'm going to do. I'm going to use the Pythagorean identity on this one and just change it so it becomes sine of x times cosecant squared of x. Then I know that cosecant can turn into sines, so like cosecant squared. Well, cosecant is equal to 1 over sine, so cosecant squared is equal to 1 over sine squared of x. So then when and that's a reciprocal identity that I'd use there. And then I multiply this stuff together and I get sine of x over sine squared of x. And one of the sines cancels out and I get 1 over sine of x. And that's another reciprocal identity. And that'll lead me to cosecant of x. And that's as simplified as it gets. And then we'll do one more, and then we'll go on to a new video for the verify problems, which tend to go a little bit faster, especially when you practice some of these different methods that we've gone over. Okay, on to number 8. So I see a sine, a secant, and a tangent. So I guess like one thing that's been kind of common around here is that, if you look through all the work that we've had, a lot of them are dealing with sines and cosines with the exception of 2, so of number 2. So like, if you have a bunch of different ratios, like one thing that you can always try if you get stuck is just to turn them into sines and cosines. That's what I usually do if I just want to kind of get a problem done rather than find the easiest way. And sometimes it actually does lead to a really easy way, but in this particular case, I just probably change them all and see what I get. So let's see what we get with this. So we have sine, right? And then we have secant. So I'm going to turn that secant. Let's see, secant is 1 over cosine. So that turns into, with the reciprocal identity, into 1 over cosine. And then tangent, I'm going to use the quotient identity and turn tangent into sine over cosine. So that's what this one's going to become, sine of x over cosine of x. And you should kind of see what's going to happen soon. I'm going to multiply these two together so I get sine of x over cosine of x. And then that is being divided by sine of x over cosine of x. And you can see that it's a number over itself, so that just reduces down to 1. So that's as simplified as it can get. So that's all the simplify problems. I think that's a good place to stop. Then when we get on to the verify problems, it's going to be quite a bit easier to work through those. Okay, so that's it for this video, and then on to the next one.